Compare rational numbers. Compare the numbers, then name a number that is between them in value. Question number 1. -5 and 3/10 compares to -4 and 9/10. To make this an easier comparison, I am going to change -4 and 9/10 to a fraction. -4.9. If we graph them on a number line, -5.3 would fall here, and -4.9 would fall here. This means that -4.9 is greater because it is on the right. Now, what numbers fall in between these two numbers? We can count from -5.3 backwards to -4.9, or we could count from -4.9 to -5.3. If we start at -4.9, the next number would be -5.0, then -5.1, then -5.2, then -5.3. Question number 2. -1/5 compares to -3/10. To change -1/5 to a decimal, I would do 1 divided by 5. This would give me 2/10. Remember, this is negative, so my answer would be -0.2. If I plot them on the number line, -0.2 would fall here, and -0.3 would fall to the left. This means that -1/5 or -0.2 is greater because it is on the right. Now, what number or numbers could fall in between? I'm just going to give you one example. What is halfway between 0.2 and 0.3? Well, what is between 2 and 3? Think about that in your head. Well, it would be 2.5. But this is actually a decimal point, so it would be 0.25. And they're negatives, so it would be -2.5. Question number 3. -2 and 4/5 compares to -2.5. One thing that you can do to make sure that you are comparing equivalent fractions is to rewrite the fractions so that they have common denominators. In this case, a common denominator could be 10. 5 times 2 is 10. 4 times 2 is 8. 2 times 5 is 10. 1 times 5 is 5. So on my number line, I can now record both of these fractions. -2 and 5/10 would fall here, and -2 and 8/10 would fall here. So what could go between these two numbers? Well, we have 5/10. We can make it 6/10, 7/10, 8/10. So our answer would be -2 and 7/10, -2 and 6/10. I wrote these as fractions, but you could write them as decimals. Question number 4. -7/5 compares to -1 1/10. Now, I am going to write this as a fraction, and I'm going to change -7/5 to -14/10. Then I'm going to change this number to -1 1/10. So this would then reduce to 1, -1, and 4/10. So now I can plot these on the number line. We have 0, we have -1 1/10, and then we have -1 4/10. So what can fall between these numbers? Well, we can count backwards, and I apologize, this should be a 2. Okay, -1 1/10, then we have -1 2/10, then we have -1 3/10, and then we have -1 4/10. Question number 5. 25 hundredths compares to -1/10. Now, to help me, I'm actually going to make this also hundredths. So I have 25 hundredths compared to -10 hundredths. I'm going to put this on the number line. Oops. Yeah, here we go. So I have -0.10, and here I have 0.25. Well, right off the bat, I know that 0 has to fall between these two numbers because one is negative and one is positive. There's a whole slew of numbers that fall between these two, and I'm going to show them to you now. Okay, so if we start at 25 and work our way down to 0, we're going to go 0.24, 0.23, 0.22, 0.21, 0.20, 0.19, 0.18, 0.17, 0.16, 0.15, 0.14, 0.13, 0.12, 0.11, 0.1 or 0.10, and then 0. And then because I'm counting by tenths or parts of tenths, hundredths, my next number would be then it would be 10 hundredths. So here are just a few numbers that you could have that fall in between. I think the most popular answer should and would be 0. Question number 6. -3 2/5 compares to -3 6/10. I'm going to change 2/5 to a decimal. 2 divided by 5 is 0.4. So this would become -3.4. So what numbers would fall between -3.4 and -3.6? Well, there actually is, well, if we're only going with tenths, there actually is just one. Now, of course, if you're going to go down to hundredths and thousandths, you could get more detailed, but a clear answer would be -3.5. Problem number 7. -4 3/4 compares to -4 7/10. Now, I'm hoping that you know that 3/4 is 75 hundredths, and this would be 4.75. And I can add a 0 here, so that makes it easy to compare. So on our number line, I would have -4.70, and here I would have -4.75. Here are some numbers that we could have between these two integers. Negative 4.71, negative 4.72, negative 4.73, negative 4.74, and that takes us back to negative 4.75. Question number 8. Now for this question, I am going to use a fraction just because 8 doesn't really lend itself well to tenths, which then can be converted easily to a decimal. So I'm going to convert these fractions to fractions out of 40. So this would become negative 5/40, and this would become negative 16/40. All right, so I have 0, and this would be negative 5/40, and then negative 16/40. And now we have to count our way from negative 5/40 to negative 16/40. Okay, so negative 5/40, and then we have negative 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and they're all negative 40ths. Question number 9. What steps did you use to solve problem 2? Now, in problem 2, we were comparing negative 1/5 to negative 0.3. Step 1, I converted negative 1/5 to a decimal, negative 0 2/10. Step 2, I listed the two numbers in order, negative 0/3, negative 0.2. Step 3, the number between 2 and 3 is 2.5, so my answer is negative 0.25.